Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Hello students, I remain my humble self, Mr. Salami EA. Welcome back to another physics class again. I'm going to introduce to you energy stored or work done in a spring, or you call it an elastic material, because spring is an elastic material, as we have discussed in our previous classes. The work is done by force in stretching the spring through the displacement or extension. Then the work done in an elastic material is the product of average force and the extension or displacement. That is, work done equal to average force multiplied by extension. Then, after gotten that, we say work done equal to what? Average force multiplied by extension. What is average force? Average force is equal to initial force plus final force divided by 2. Then at initial stage, force is always equal to what? 0. And when force is 0, then what we are going to have as our average force now becomes 0 plus F divided by 2. Average force now equal to 0 plus F divided by 2. Then what we are going to have as our average force now will be equal to what? F all over 2. Then substitute what we have now back to our previous equation. We now have work done, which is W, equal to what? F all over 2 multiplied by extension. Because we said our work done equal to what? Average force. The product of what? Average force. What we mean by product? That is multiplication. Product of what? Average force and extension. What we have as our average force is F all over 2. What's our extension is E. Therefore, work done, which is W, equal to what? F all over 2 multiplied by E. Then you will now have it as this. Finally, we'll have it as what? This F all over 2 we have here now is the same thing as what? 1 all over F. F all over 2 we have here now is the same thing as what? 1 all over 2F. 1 all over 2F. And when you multiply 1 all over 2F by E here, you have your W equal to what? 1 all over 2FE. 1 over 2FE. Then you now represent this equation as what? Equation 1. You represent this equation as equation 1. Then go back to Hooke's law from our previous lessons. We said that what? Hooke's law, from Hooke's law we have F equal to what? KE. Then if F equal to KE, whenever you see F in equation 1, put KE there. In this equation now, instead of us to write F here, what's our F from Hooke's law? We have it as what? KE. Instead of us to write F now, we will not write F again. You will put what? KE. Then from there you have your W equal to what? 1 all over 2 multiplied by, instead of F you see here now, what is our F? KE. You will use it as what? KE. Multiplied by this final E here. From there you have 1 over F multiplied by KE multiplied by what? E. And when this E is being multiplied by this another E, you have what? E squared. Then finally we have what? W equal to what? 1 over 2 KE squared. Then if you like, you can also represent this one as what? Equation 2. Then where W equal to what? Work done or energy stored in a spring. K equal to what? Elastic constant, and E equal to what? Extension. Then note that equation 1 and 2 can be used to solve for the potential energy in an elastic material. In an elastic material, if you have to look for potential energy, it's different from when a body is moving from one point to another, or when a body is standing and you have to look for the potential energy of such body. It's different from the potential energy in an elastic material. In an elastic material, if you have to look for potential energy in an elastic material, you can also use W equal to half KE square, or W equal to what? Half FE. Half FE. Not in this case now, we don't use mgh as the potential energy. This is what you can use equation 1 and 2 as far as what? Elastic material, work done in an elastic material is concerned. That is that for that, for today's class. In our next class, we shall move into the solving question or solving problems concerning this particular topic. Thank you and God bless you.